Let's finish off question 4 in this video. So recall, we stopped in the previous video with this rejection region. So we found out what should be our sample data, what are the extreme points of the sample data that allows us to reject the null hypothesis. When we speak about the power, because that's our purpose, the power is a probability. It is a probability of rejecting the null hypothesis. So let's write that over here below. The power, P, that we're looking for, let's call it like that. Let's say it's power, so we know, we don't confuse it with p-value. That's equal to a probability, so P stands for probability, that we can reject the null hypothesis. So the probability of rejecting the null hypothesis means the probability of finding such values when the sample mean is greater than this number, 2087, or it is less than 1312. That's the probability that we're looking for, but we have a condition for this probability. Given that the true population mean is 1600, that's given in the question. So we have a new piece of information. That assuming that this value is going to be 1600, what is going to be this tail? So this tail is going to change because the probability is going to be again the difference between our sample mean and the population mean in terms of standard errors. We're still going to use our Z standardization to see how many standard errors away is 2087 farther from 1600. So let's do so. We're gonna have two pieces of probability. We're gonna have here a tail on the left side and another one on the right side. So let's do, first things first. Probability that now we're gonna standardize this x value into z value. So the probability that we're gonna have a z value greater than or equal to, we're keeping the same sign, greater than or equal to 2087.06, but remember we have to subtract that 2087.6. we have to subtract the population mean, and we're dealing with a $1600 population mean. So relative to 1600, how far away is it in standard errors? So we use the same standard error as below, that as always 2833.33 divided by square root of 145. Now this value is going to be equal to 2.07, so that's equal to 2.07. The probability that z is greater than or equal to 2.07. Recall, in the table, if we look at graphically over here very fast, z like that, the mean is 0. 2.07 is going to be to the right, so 2.07. We're looking for this p-value. This is given to us when the value is less than a number. So in our z distribution, they give us the probability that z is less than minus 2.07. So we're going to look there and find out the exact same answer. We could also use 1 minus this probability, but in my experience, this is faster. We just look at the opposite value and look for the left tail. So the probability that z is less than or equal to minus 2.07 according to the table would be equal to 0.0192, so that's 1.92%. We got one piece of probability. We do the second one as well with this number in mind. So if we are looking for sample data that's less than 1312, we're looking for a probability when we standardize it. So what is the probability of having such result given that the true population mean is 1600? So the probability that the z value is less than or equal to the standardized value, which is going to be the difference from the sample mean of 1312.94 from the population mean that we assume now, minus 1600, divided by the standard error. And the standard error is the same as always, which is 2833.33 over square root of 145. We solve the math over here. We would have the probability, that the z value is less than or equal to minus 1.22. This is already given us as a left tail, so we have nothing to change there. We just look in the table. That probability is equal to 0.1112. Now, the probability on one side and the probability on the other side is going to give us the total probability of rejecting the null hypothesis, which is going to be our power. So we're just going to add the two numbers, and we see if it makes sense graphically, this number. So 0.0192 plus 0.1112, we do the math, that's equal to 0.1304. So what's that? That's 13.04%. 13.04%. Now notice, let me just zoom out, hope I can get everything in one space, because this is really gonna help. Hold on. Here, yes. Now check this. You see, we used to have these values. over here. The z value was 1.645 and minus 1.645. In total, these two tails made up 10%, right? It was 5% and 5%. That was given in the question. That's equal to alpha. Alpha was given to us as 10%. Now notice this. We found out the power to reject the null hypothesis when the mean is 1600. So what we got as a result is that the z value eventually that we found on one side and on the other side are so it was 2.07. Over here it was 2.07. Let me try to draw it like that. It was hope this is visible, 2.07 over there. And on the other side it was minus 1.22. So minus 1.22 is gonna be closer over here. Minus 1.22 is somewhere over there. Minus 1.22. Now these areas, let me shade it in a different color. These are the power that we're looking for. This is the tails that we added. This is one probability and this is a new probability. The left probability, the left tail increased quite a bit. So all in all, these two areas increased from 10% in the beginning to 13% now, and the 13.04% is the probability of rejecting the null hypothesis that we were trying to reject, given that we have a different mean, given that we have a mean of actually $1,600. Anyway, hope this zoom out helped. You can watch it again. Hope this all makes sense, and we're done.